All right, good morning, everyone. Hello, hello, good morning. Hey, everybody, welcome to the hackathon. Thanks so much for showing up so early on a Sunday morning. Anybody here their first NANOG hackathon? Oh, okay. Excellent, well, welcome. And anybody that had their hands raised first hackathon in general? Okay, a fair number of people. And is from the people that are competing or participating for the first time, how many are network engineers who are new to programming? Okay, and are there any, okay, a couple. And are there any programmers here that are new to networking? Oh, wow, excellent. Well, welcome. So I'm going to go over a couple of logistics. I'm Michael with the program committee. I'm going to go over a couple of logistics before handing it off to Akshat, who is going to go over what you're going to be working on today, should you choose to take part in that particular hack. So first, I want to thank our sponsors, Cisco and Tessuto, for providing the infrastructure today. I'm going to talk for about another minute and then hand it off to Akshat, who's going to give an introduction. After that, people are going to break into teams if you haven't broken into teams already. We want teams to be no less than 6, no more than 9. If you're like a 1Z, 2Z team and need help building a team, please come and see us afterwards. The people that are going to be helping out with this are these 2 tables over here in the corner, and then the other table about 4 down. Could you wave your hands, Cisco? Thank you. We're going to break into groups as soon as Akshat is done with the introduction. Lunch is going to be here. If anybody needs to use the restrooms, they're down the stairs, right outside the door. And then the break is taking place in this room, except for the reception, which is going to be just outside on that raised platform. And then besides wishing everybody luck and wishing everybody to have a good time today and hopefully learn something new and hopefully meet new people, please, as you're working on your hacks, take the time, and I'm going to say this probably once or twice more today. This lab infrastructure is going to be broken down at the end of the day, and you're going to need to do presentations at the end of the day, and the best teams are going to be presenting at the conference. So whatever you do, if you're taking screen captures or doing movies of some script that's running, please make sure to be documenting this as you're going along today, because it makes doing your presentations at the end of the day way easier. And again, if you have any other questions, please come and find one of us. And now I want to hand it over to Akshat.
All right, can you guys hear me fine? All right, so we've got a really long room. What I would actually prefer is as many people as can actually come by to this table and to the tables in front. It'll be easier for you to see what's going on. And we'll then be able to, both show here and then discuss how to arrange the groups. What I want to start off with is actually explaining all of the different components that we have as part of the hack, some of the things that we'll do, and there's a difference in the way we're arranging the hack this time. So some of you who've been to other hackathons earlier might not be used to what we're going to do. So let me actually dive into that and explain. Can I have some of you at least move in, the ones who are really at the back? Come by here. It'll be really tough for you to see what's going on otherwise. All right, all settled. So what I want to start off with is to get each and every one of you on the website that's actually going to host your instructions for today. Now, Can I have everyone browse to nanog75.github.io/hackathon? nanog75.github.io/hackathon. Let me just put this on a terminal. All right. So let me now sort of give you an introduction of what we plan to do today with the hack. This is the topology that we've brought up for everyone to actually use. We've gone through a few hackathons earlier at NANOG where either we've not had an infrastructure in place or the infrastructure that's been in place is not necessarily used by everyone. What we wanted to do this time is give you an infrastructure that is in place and has everything that you would potentially need, but at the same time give you some amount of flexibility in being able to do something with respect to your own tools or the way you'd like to combine things, right? So we've tried to mix and match those possibilities. So in case you find that you have to stick to a certain paradigm of what we ask you to do, bear with us because there are parts of the hack where you will get to experiment and add your own pieces, right? But what we wanted to do was create a topology, create a goal that you need to attain as part of the overall hackathon. And the way in which you accomplish it, and of course the code that you write is up to you, right? But the specific set of tools that are available that are already working and they are provided to you as base code is very useful because you can start using that and adding your code on top. There are some things that might be entirely new and complex for folks who've never coded before. And therefore, introducing that from scratch might be a burden. That's why we provided base code for a lot of things in the hack. Now, this is the topology we're going to use. So thanks to Suto, they've actually spun up a number of pods for everyone to use. And these are all instances that are hosted on Google Cloud. And also, as the topology shows, there are 4 routers in there. These are all iOS XR instances. And they are meant to basically provide the APIs that you will utilize through the hack. And those APIs deliberately have been selected to be either community-driven or vendor-neutral APIs. So anything that is XR specific is already coded up for you, right? Which means that it remains hidden, just use it as is. And for all the OpenConfig-related, community-related APIs, you get to code on your own, all right? Now, you will also notice that you have these 3 other boxes floating around those 4 routers. These are the development instances within the setup. There are 3 development instances for a reason. What we intend to do is actually divide up each team into 3 groups. Okay? Now, these 3 groups are meant to actually handle different parts of the hack. However, they feed into each other to actually accomplish the final goal of the hack. This is all about operations and automation, which essentially means that we're trying to, one, delineate between the different types of operations that you can have on a network. There is no fixed terminology for this, so we're coming up with this stuff on the fly, but it sort of makes sense to some people, so we're sticking with it. When you consider day 0 ops, we're essentially talking about the time when the box boots up without a configuration, and therefore it needs to either get a config or run a script so that it can be brought to a bootstrapped state, right? So day 0 ops is going to be one particular group within your team, right? This particular group is responsible for running a script when the box boots up, and the version of the XR instances that you're running also have NC client support as part of the base image, which means that you have to use models only to go ahead and configure the system. If you use CLI, it doesn't count. All right? So the entire infrastructure as well as the parts of the config that we're going to utilize have been set up in such a way that you don't actually have to use CLI anyway. So wherever you feel that CLI is going to be utilized, reach out to us, and either we'll find another way or we'll figure out what's wrong, okay? So in the entire premise, as you go from day 0 to day 1 to day 2, each one of them tend to feed into each other and sort of serve up another piece of automation characteristic that the next group has to solve. But we recognize that you cannot have one group wait for another group to actually finish. So we've separated out the concerns in terms of which set of routers are available to which group at any given point in time. Okay? So to start off, when you consider day 0 ops, going back to this topology, right at the top is what we have router 2. Right? Router 2 is the one that's going to be available for the day 0 folks in order to do ZTP. Do not do ZTP on any of the other instances. That is, do not reload them, do anything of that sort, because the other groups will be utilizing them. And the other groups, remember that the router 2 is not going to be available to you for your automation. So whatever you automate, do not try to include router 2 in the set of hosts that you automate against. Okay? Things are already set up for you with that perspective. And so as you look at the code, you'll sort of realize how to get along. The second aspect is coming to day 1 ops. Now, I mentioned what day 0 ops is. Day 1 ops is essentially about more of a network-wide automation and configuration management tool usage. And we wanted to concentrate on Ansible primarily because it's probably the simplest of the lot. And a lot of people seem to have experience with it. So you can, even if you've never done it before, look up, go to Stack Overflow, go to Ansible documentation, whatever it is, and you can pick out snippets that you can utilize. Okay? And we've already done a lot of the code for the playbooks for you as well. The goal that you have as part of the day 1 ops group is to create a single Ansible playbook at the end that does all of the operations that you need to do. Right? All the playbooks that exist have to feed into that single playbook. Right? And there are a bunch of things that I'll discuss in terms of what you actually need to accomplish as part of it. Now, within the set of APIs that are to be utilized, some of you might have heard of these APIs, some of you might have not, right? But a lot of this comes from the OpenConfig community in terms of the APIs that they've been working on, the type of interactions that they've come out with, both for configuration management, telemetry, as well as ephemeral state APIs, okay? So I will talk about all of these and you'll sort of see how they work together. So on the day 1 ops side, while you will be using Ansible in order to create your final playbook, the underlying tools that Ansible will actually involve things like YDK. How many of you have heard of YDK? Okay, so it's a Yang development kit which essentially creates objects out of Yang models and you can code against them, right? We're going to use YDK Py primarily so that you will be coding in Python throughout the exercise. Second is OpenR. How many of you have heard of OpenR? All right, so it's an open source IGP essentially, comes from Facebook. Sometime in 2017 is when they released it. And we've got OpenR as Docker images available. We will be spinning them up on the routers as IGPs, okay? There is a specific reason why they're coming up. They are effectively meant to be there to bring your BGP session up. As you go through the hack, you'll realize how that works, okay? In addition to that, we intend to use GNMI. How many of you have heard of GNMI? All right, so GNMI again comes from the OpenConfig community, and the purpose of that is that it is in parallel to netconf. It's another way of actually interacting with the box, right? So it allows you to do configuration management using Yang models. It allows you to do telemetry using Yang models, and it can be combined with other set of APIs that we'll go to day 2 with, okay? So YDK itself has GNMI support, which means that you will actually be utilizing YDK with GNMI, okay? And OpenR will also be utilized in order to actually bring your reachability up on all the devices. The last part, which is day 2 ops, is primarily focused on creating LSPs, label switched paths, on the fly, okay? So there is, if you go back to the topology, Dev 1 and Dev 2 are separated by an entire set of routers in the middle, right? They are not able to reach each other until there's an actual path that's established. The day 2 ops guys have a new API that's now available called gRibeye, which also comes from the OpenConfig community, and it is meant to be able to get you to push labels and routes into the rib as well as the label switch database of the router so that you can create LSPs on the fly. There is no configuration involved in these, right? There's a specific API and you can utilize that once you create those bindings out of the proto file. Again, because this is entirely new, we don't expect people to start coding this from scratch. So we've created the code for you, right? The only thing that you have to therefore do is understand how the JSON abstraction works, create your own JSON files, and then create a higher level controller, which basically is able to push different LSPs into the routers as different events come in, okay? So day 1 folks will create telemetry information, which will be fed into day 2. And day 2 guys will use the telemetry information and change the LSP paths on the routers. Okay? And as you create LSP paths, dev 1 should be able to ping dev 2. Okay? What you will be able to accomplish if you complete the entire hack, day 0, day 1 and day 2, is that during day 0, you will have a single ZTP script which is available for all the routers, and it is able to pull the right set of Yang modeled XML files that can be used to provision the devices. You will have a single Ansible playbook which is part of day 1 that will be able to then go ahead and run all of the configurations that are required, again using Yang models over GNMI, bringing up OpenR, bringing up BGP, testing out your pings across all of your routers. And last is the day 2 guys who will have a controller that will listen to events such as interfaces going down along paths and using that to trigger LSP path generation. Okay? There are quite a few pieces here, and as I mentioned, a lot of it is already coded up for you. Now what I'd like you to do is actually take a look at the documentation that's available so you can gather what's been done with respect to things that you can sort of build out of. Each one is a separate tab, day 0, day 1, day 2, right? What I'd like you to do as soon as I'm done is to discuss who's going to be part of which group, right? Whatever you feel comfortable with, go ahead and form that group and then start concentrating only on that piece, okay? And it doesn't really matter if it all doesn't come together at the end. The whole idea is that you should be able to focus on the piece that you have and see if in the end you're able to meet a goal of bringing ops for that stage to the completion stage, okay? Now, if you go for day 0, for example, there are 3 sets of instructions here. They basically explain to you, 1, what is ZTP for people who do not know. It also explains how to perform ZTP manually. You don't have to every time wipe out the disk of the device, reload, and then wait for 10 minutes. You can do it within a few seconds, right? So do manual ZTP, follow the instructions there. And you also have the last step, which is actually taking a CLI configuration and converting it into Yang XML. And once you have that, you have to set up your infrastructure such that when the device reloads, it's able to get the right script and bring it to the final stage. Okay? And therefore, the exact configurations that are utilized are part of the instructions here. So I would implore you to start reading through it and then figuring out what it is before you start hacking around with all the components. Okay? In addition to that, we have day 1. Day 1 is also divided into 3 parts. 1, it explains to you what are the day 1 operations that are going to be involved. Okay? Second one actually teaches you what YDK is, what does that script actually look like, and the code, as I mentioned, is already done for you. The only piece of the code that you'll have to add is take a Yang model, figure out what objects there are, and actually add a small piece of code that makes the whole script work and push the right configuration. Okay? You'll see it as you read along. In addition to that, we've already created a telemetry collector for you using YDK and GNMI. So your task is to actually set up that telemetry collector so that it starts receiving information. Okay? As you go through the instructions, again, it will tell you what you have to do. And if you have any questions at any point, or you feel like you don't want to do that and want to do something different, we can discuss. Okay? And of course, right at the end, your BGP sessions will only come up once you have OpenR running. Okay? The playbook for that exists already. You just have to run it. The whole purpose of the end goal is to make sure that playbook becomes a part of your final playbook for the day. Okay? So your single playbook should invoke all of these playbooks that you create at the end. And then finally, we have day 2. This is probably, in a sense, simplest of the lot because the code is already done for you. You just have to understand what this API is, understand the structure of the JSON files, which is explained here, and then construct your own JSON files that can help create LSP paths. It can get confusing, so it requires somebody to sit with some pen and paper and actually write down what labels go where and what routes go where. Okay? So the primary purpose of this is for you to understand how this API works and then try and utilize that to actually create a controller that is able to perform these tasks. All right? Any questions at this point? Any concerns? Yes? No, so you're free to create your own Git repo for this. The actual base code is in a Git repo, so those instructions are already present. So as you go along, it'll ask you to clone and use that code, right? You can then create your own Git repo and push your code changes there. Yeah. Yes.
Are you going to leave all these repos up after the hackathon?
It's all public. Yeah.
Okay.
Yeah. Also, there is a repo that has completed code. I'm keeping it private for now. If people have trouble and they're not able to complete something, I'll make it public. Okay, and then you can sort of look at that and then see how to make your code work. All right. So the first repository that you have access to is incomplete code. It works, but it doesn't take you to your final stage. So you have to figure out how to make that work. All right. Cool. Okay, so as I mentioned, there are totally 6 instances or 7 instances in the overall topology. Each group is going to have access to 1 dev instance each, right? So there is ZTP dev instance for group day 0, and then for day 1 it's dev 1, and for day 2 it's dev 2. Okay, and the instructions to connect to them is all on the website. When you click on connect to the pods, it tells you exactly how you're supposed to connect. Plus, I believe the pod numbers have been given to each one of you. Right? So based on that, you should know what your URL is and then use that accordingly. All right? Okay. So let me quickly show you what's running right now. I'm on a fresh instance, and therefore this is basically the jump box. The instructions also show you that from the jump box, you can actually console into the routers as well. Particularly for the ZTP folks, this is absolutely essential. Right? Because as you're doing ZTP, if something goes wrong, you might lose access. So you need console access to make sure you can correct it. Okay? So once you're into the jump box, which is the main URL, you can basically get into any of the instances by using the name, router 1, router 2, router 3, router 4. Okay? And the username and password that you have to use is router dev and NANOG 75SF as the password. The instructions are there on the website. All right, so a quick representation for the folks who are going to do day 0. Okay, that is ZTP. How does this actually work? This is my ZTP instance, right? This box contains 2 entities, a DHCP server and a web server. When the router boots up or tries to do ZTP, it sends out a DHCP request. Based on the serial numbers identified in the DHCP request, the ZTP instance or the DHCP instance on the ZTP is going to respond with the location of a script, right? That script will be executed on the router, and it should bring the router up to the final state. Okay? Majority of that script is already written. The only thing that you have to focus on is making sure that you figure out the right Yang model XML paths, and then write the code to be able to use NC client on box. That's all, right? So let's quickly take a look at this. It's too small. All right. So on the web server, there is a structure that's available. Okay, so there are configs. Configs actually contain the final configs that your routers need to reach. Okay, you have to take a look at that and then try and figure out what is the XML that I need to actually reach that state. Right? It is quite well explained in the instructions as well. How do you do a diff? What are the CLIs that you actually need to convert? And then you'll sort of get going based on that. There is also a package that the script installs. It installs pip as part of the bring up process, and then it can be used to install packages of your choice on the router. Right? As an example, as part of the script, we install XML to dict, which means that it is able to convert your XML to dictionaries. And that, I think, is fairly useful for a lot of folks who are working with XML data. You can choose to install whatever other particular package you need. The script allows you to do that. Now, the script that gets downloaded currently as part of the ZTP process is essentially here. It's called ZTP nclient.py. It does a bunch of things, but primarily, as you can see, it imports NC client on the box when it runs there. So NC client is part of the base image. And you can ignore much of the initial part of the code. It is basically setting up. There are comments everywhere to explain to you what this piece of code does. Read through it, understand what it does, and then you can incorporate more. And the serial numbers are extremely important. Okay? Serial numbers are used by the DHCP server to give it the right IP, as well as the right script or config that you need to provide. And the script itself can use serial numbers to determine where to download XML files from. So you can structure your web server in whatever way you like, map your serial numbers to router names, which is already there as part of the script, and use this map to make the correct requests, the curl requests from your script itself. Okay? And as the code goes on, at one point you will see that the NC client manager is created for you, and a very simple get config is done. Right? So it is able to do a get config, get an XML format of the running configuration. All you have to do is now figure out your actual XML config, do an edit config appropriately, download those files wherever required, and at the end do all your error checks until the script completes properly. Okay? The steps to actually run them is all on the instructions as well. All right. Now, a quick look at what actually makes this go. The DHCP server has to be set up to actually respond with the right entities, which means that this is, again, already done for you. And you can see, essentially, for every router, a corresponding IP, it is statically assigned right now because we use that IP for NATing purposes, right? So you don't change that at all. The only thing that you're interested in changing is this boot file name. All right? So either you can supply the config directly if you just want things to work, or you supply your script, which is the one that actually gets downloaded when ZTP happens. Now, there is absolutely no need to always perform ZTP in order to get the script running. You can simply download it from the web server and run it locally to see how the script is working, right? So do ZTP only when you need to try it for the ZTP process. Otherwise, run it like a normal Python script on a Linux box. That's all it is. So let's, for example, get into, I'll get into router 2. Now, router 2 deliberately has been brought up to only a very basic state. It doesn't have the full configuration, right? This is the guy that the day 0 group will be focusing on. So you will try and download the script through ZTP or directly, and then try to make it work until it gets to the required config. How to create those XML files is explained in the instructions. So as part of this, as an example, just to get this going for now, I'm not going to change the script currently. I'm just going to change, for example, on the DHCP server. The boot file name to the actual config file so that it quickly brings it to the required state. And whenever you make changes to your DHCP server, make sure you restart it, otherwise the changes will not take effect. Okay. And there are quick instructions like these available to make it do manual ZTP quickly, right? So this will force the router to send out a DHCP request and then try and fetch the script that's required. Now, as it does that, you have some options in terms of setting up your ZTP instance to actually see what's going on. You can use DHCP dump, which gives you the exact DHCP requests that are coming in. You can also, as you can see, this is the file that was provided by the DHCP server in response to the request that came in from the router. Right? This is the basic ZTP process working. Now, instead of this, you will be providing the script, and the script is what you have to complete. All right? Now, as this gets applied, I don't expect any syslogs, but when you run the script, there are utilities within the script to actually send syslogs out. So you can look for syslogs on the ZTP server. You don't have to go to the router, right? And it'll come on port 514. So listen to that or set up your own syslog server if you need, and it'll give you details of what the script is doing. Now, since this router is about to come up, what we can do is actually take a look here. Yep, you can see the interface is coming up. This is the config getting applied to the router. Okay. So now this router is pretty much up there with the final state, right? And this is what you need to accomplish as part of your script as well. Okay. Now that's what day 0 folks will be focusing on. Now let's consider day 1. As part of day 1, what I'll do is jump into dev 1. That's your instance. You have access to all 3 routers, router 1, 3, and 4, not router 2. That's for the ZTP folks. So you will be therefore running your Ansible playbooks against all of these 3 instances. Whatever the day 2 folks will be doing is not going to impede you, so they can continue to work on their own, and it's not going to affect what you're doing. So, but the 2 of you will share those 3 routers, router 1, 3, and 4. Okay. Now on dev 1, what we'll do is I'll clone my instance, which is the completed one. Okay. All right. Now this has already been arranged for you to actually try out the code as needed. Ansible, telemetry, YDK is all for day 1. ZTP is basically for the day 0 folks. And gRibeye is for the day 2 folks, right? And the code in each one of them is set up accordingly. Now let's take a look quickly at the Ansible playbooks available. The playbooks are set up into 4 different categories, right? So there is config BGP, which is going to configure BGP between router 1 and router 4 using YDK and GNMI. OpenR bring up, which is basically going to run Linux commands and bring up a Docker container on all the instances. Reachability check, which is again going to use YDK in order to test pings across all your network to make sure that OpenR was able to distribute properly. And the telemetry setup, which you have to do on your own, is to figure out a playbook to spin up a Docker instance of the telemetry collector. Okay? Those instructions are all in there, so don't worry. Now, the day1.yaml that you see here is, in the end, simply importing all of the other playbooks for me, right? So I will execute just day 1, which is also your end goal anyway. Have a single playbook that then goes ahead and calls all the other playbooks in order. So let's try this. Okay. Yep, so all my instances are ready. Okay, so this is going to start connecting to my routers. It was able to configure BGP properly for me. Now, this guy is actually going to restart the Docker daemon on all the instances because of the routing changes that took place. And then it's going to pull the Docker image. That takes a little while, so let it run, right? And on each of the routers, it's going to pull almost like it's a 2 gig Docker image, so it takes a while. But all of the routers will pull that Docker image and then eventually spin it up, okay? While this runs, you can actually even go to the router and see what's happening. So let's say I'm on router 2. Now, good thing is, of course, Ansible runs in parallel, so it's going to pull the Docker image on all the routers in parallel. And here, for example, you can see it's about to initiate the Docker pull anyway for me. And if I just do a df -h, it hasn't started the pull yet. But effectively, the app_host directory that you see here, that should fill up with the contents of the Docker image, and as it downloads, you can see it incrementing, right? That's one way of checking that it's actually working properly. So all of these different routers, as they pull, we'll wait for them to actually come up. Now, in the meantime, let me actually show you what happened with the first playbook that ran, which is YDK configuring through GNMI. So this is the configuration that was pushed to router 1. It's a basic IBGP configuration, right? So it's trying to set up a BGP session between router 1 and router 4, which is the end router, okay? And this session is not going to come up because of the fact that we're using loopbacks to peer, right? And the loopbacks have not been distributed because there's no IGP running, which is why you have to get OpenR running, okay? That is why if you were to take a look at show BGP sessions, you can see it's idle, right? And we'll wait for the Ansible playbook to complete in order to get to our required state. Where did I go? Yeah. Okay, let's see what this guy is doing. Yeah, you can see it filling up. It's like 1.4 gig now. So it'll reach 2 gigs soon. That's basically the Docker image being pulled out. Almost there. Okay, I think it's going to be done. Yep. So now it's going to push all the files as needed. And yep, so I got the hashes for the OpenR instances, right? That means all the Docker instances were brought up on the 4 routers. Now it's going to, I've put a pause for like 120 seconds, it can be less. It depends on how long OpenR might take to actually get those routes. Usually I've seen it happen within 30 seconds, but I've seen it fail as well, so I'm just being a little bit conservative. So put your pauses within the playbooks as necessary, because in the end your playbooks have to test conditions. So in this case, my next playbook is supposed to make sure that every router is able to ping the loopback of every other router, right? And therefore, as that list is passed in, OpenR should be running and should have distributed the routes for me, okay? So let this guy keep running, and I can actually go back to router 1. You see the BGP session is now established. That is primarily because OpenR came up. Now let's do a show route. And do you see these application routes, A routes at the end? These are routes being learned by OpenR from other OpenR instances, right? So you're running a third-party protocol separately as part of the vendor stack. So the third-party protocol can then be utilized for all of its own APIs, and you can combine it together. Now, once you have these OpenR instance running and BGP session has come up, of course, I can actually just make this guy start quickly. They should start testing the reachability of the loopbacks for me. And this is actually using YDK and GNMI to invoke the APIs of the XR router to actually do pings for me, right? Because it's not a Linux instance, so I can't just ping. So this guy is actually utilizing the APIs for that. So you will be creating your own Ansible module as part of the exercise to make this work. And then I'm going to spin up finally the telemetry collector as a separate Docker instance. And one interesting thing is the way we make the day 1 guys give the telemetry information to the day 2 guys is through a Kafka bus in the middle. So your telemetry instance that you spin up is going to push to Kafka, and the day 2 guys are simply going to run a consumer, right? And the consumer will start getting the information needed. So you are able to isolate your telemetry concerns, but at the same time feed your data into day 2. Okay? Okay, it's probably pulling the Docker image for that guy as well. Okay, so now while that is going on, I can actually jump on to day 2. Day 2 is where we're trying to build a simple controller that is able to push LSP's paths into the routers so that you're able to finally get reachability from dev 1 to dev 2 at the end. Okay, so for that purpose, let's get into dev 2 here. I'm going to try and ping 10.11.10, which is actually the IP address of dev 1 at the far end across the entire topology. Okay, it's not going to be able to ping. So let's get into now we're going to use gRebuy. gRebuy is the new OpenConfig API that's come out. It is not a configuration API. It's an API that creates state directly into your RIB or into your label switch database, which means that you can set up LSPs on the fly. It's like segment routing, but the policies are in your controller or app. There is no configuration at all on the devices. Okay? And the state, of course, is only maintained for a certain period of time. You can purge it whenever you need. And basically, your controller is the owner of that state. All right? Now, here, we have a few folders available. The protos folder shows you the protos that are effectively the protobuf ideal or the model for this gRebuy API. All your libraries and bindings are created from these proto files. Okay? If you go up a notch and check out the other stuff available, as I mentioned, the code is already done for you. So gRebuy API is the one that actually connects to the instances over gRPC and is able to communicate and make the gRebuy calls. gRebuy client, on the other hand, is the one that receives JSON information and converts it into a format that the gRebuy API can use. Okay? So you will only be coordinating with the gRebuy client. I have, in the code sample that you will get, I only have example for path 3, where all you really have to do is understand the JSON file that is provided here, which I explain in great detail in the instructions, so go through that. And this basically takes all of the different values of the gRebuy API and just puts it out in a JSON format so that you can read what it is, right? And you will basically be able to see how a route is structured before it is sent into the router. Okay? And in the end, you have to create multiple such JSON files for each path that you can create. In the router topology that we've shown, there are 5 possible paths. Those are identified in the instructions. So consider that, write down exactly how you would put a label here or pop somewhere else, and then you will be able to simply create your JSON files and it will work. Right? No code to be written, it's just for you to figure out how to actually push the right information into this API. Your primary goal in the end is to be able to take the telemetry data and use that to create events, right? And that's the second part. But if you're able to get through this itself, it's very good learning on its own part. All right. So let's consider, for example, I'll add to path 3. Now let me explain what path 3 is. So if you go to day 2, I sort of end up explaining all the different paths that are possible in a given topology, right? So this is path 1, path 2, path 3, path 4, path 5. Okay? So you can potentially select any one path and create a label switch path for that so that your traffic only follows along that path, right? You're trying to engineer your traffic in real time. So for example, when I give you the example for path 3 and path 2, you're basically saying when you set up path 3, then the traffic will flow through here and only there. If path 3 goes away, traffic will again stop flowing because it requires that label switched path to actually exist So let's actually try this. So I'm going to try path 3. Right? So it just ran. And you see the pings that started? The pings are going through because the LSP path was set up. I can stop this again. Where did it go? Where I delete everything that I created on the router, right? And the ping stop. So it's a very basic flow. You can even create an app that literally looks at ping information, right? And that is able to feed into your controller as well. You don't necessarily even need to look at telemetry information. This is all about how you think about doing monitoring for real-time decisions. Either the information can come from the network, which is what telemetry data gives you, or the information can come from an application like a ping, which tells you, hey, I'm not able to run. And that's enough of an event for you to try and change the LSP path. Okay? So I know these are fairly complicated things, but I've tried to explain all of these in detail, and as I mentioned, the code is already there, right? So if you feel it's too much, just start off and you'll see you'll get into it, okay? And we're all here to answer any questions that you might have, but in the end, your goal is have a single Ansible playbook, as I just ran, be able to write a controller that's able to get the traffic to flow or shut off as needed, and for ZTP, get at least router 2 up and running, right? Ideal goal would be you create the corresponding XML files and scripts for all the routers, but that means that you have to convince your other guys that you're willing to wipe their config off, which is probably not going to happen. So focus on at least router 2 and get that running, right? And in the end, if you're able to do all routers, kudos to you. That'll be a pretty good demo. All right? Any questions? Yes.
Feature request. The SSH network to these boxes is very laggy and slow.
Okay.
Did you install Mosh perhaps on servers we're contacting with that will deal with that a little better?
Potentially. I mean, it's possible that the connection from here itself is a little slow. So, but yeah. Oh, okay. Yeah, that's probably something you have to consider. Okay. Anything related to the code itself? Any questions? No? All right, let's get started. And we're all here, right? So whatever questions you have, if something doesn't work, just let us know. All right? Thank you. Yeah. Yes.
All right, everyone, start dividing into teams. If you're having any problems finding or organizing a team, please see Steve or Vince or me over in this corner. If you're having any problems setting up infrastructure, please visit the Tesudo people at this front table. And then as you're moving on to the hack itself, if you're having problems understanding the hack, please see the Cisco people over in that corner. And just to be clear, this that was presented on is one option for you to do. You're not required to do this hack. We'd encourage you because we know this material better than anything else that you might come up with, but you can work on whatever you would like to today. Any other questions? All right, we're going to be around to tables to find out who's on the team. Please, once you've organized, write down, there are sheets that have your pod number. Please write down your team name. You can make up a name if you'd like, and write down your team members' names. And then we'll be around to see how everybody's doing. All right.
Hey, everyone. Just wanted to let you know 15 minutes, and then we're going to roll into the presentations. So 15 minutes.
All right, it's 6 o'clock. Since everybody should be done at this point, we'll just go in order of teams that are from pod number. So could pod 3 please come up?
Okay, so we are neural clacks, and we did, we'll just talk about briefly what we did. So day 0, we ran a ZTP script, but it was really only basically doing show commands. So we just basically edited that and we had to do a little bit of research on the read to docs page for NC client to see kind of how to run the edit config and commit methods. So we were playing with that. Once we figured out just some test cases to get things going on that way, we installed requests. We added requests to the required pip binaries for in the router, and then the router would then use requests to loop through. We did a for loop and just loop through all the file names, the XML docs we created, to just basically pull those from the ZTP server. And this is the important bit of that ZTP script that we modified. Basically, there was a helper function called getSerialNumber we used to pull the serial, and then we made sure that the requesting router was going into the right folder to request the file, and then we basically just looped through all of our files and used etree from LXML, and then fed it that config. We did a couple print statements so we knew what the script was doing, and then wanted to show you these are the actual XML files that we wrote. A couple of the ones were provided for us, but we just added these two. A couple of notes here. We had to use the Cisco XR model, not the OpenConfig model, because we couldn't get the OpenConfig model working with the XR. But we were able to use the OpenConfig model for some of the other docs. And that's pretty much it for day 0, day 1.
Hey, good evening, everyone. We just we thought there is 2 options given to us. So one was the easy way and the other one was using YDK. So we used YDK to get all the configs, populate the classes of YDK, and then we wrote an Ansible module for that and used that to provision the router 4 and 1. And then we started to spin up the containers for Ansible. We can try to. So basically, we have not done the Ansible module for idempotency sec, so it's going to reconfigure the stuff and spin the containers up for the telemetry, and then for the reachability checks, making sure that everything is fine. That's about it. Thank you.
So we just worked on setting up the JSONs to manually configure the LSPs. So we wrote the shell scripts to interact with the JSON files to actually configure the different LSPs for each path. We had to draw out every single path and the labels that we wanted to choose, because it's kind of complicated to just think about it in your head without drawing it out first. So I can just show you, for example, how we would bring up path 2. So path 2 is the blue path, and that's just between router 1 and 4. It's still flickering. Okay, oh, there we go. Yeah, so if I run the script to add, hold on a second. So this script just added the LSP between path 1 and 2, and if I go on the jump box, I'll see the LSP in that in the routing table. Hold on. What's that? 30 seconds. 30 seconds? What is it? No pressure. So if I go to router 1, I'll see the LSP that we just added. So you see we have the MPLS forwarding label in there, and if we look at the route, we should see that application route in the routing table right here. I actually do not see it. That's weird. Okay. Anyway, we had some issues before when if we tried to add multiple LSPs at the same time. If you try to do a delete, it would fail. So you'd have to delete them in the reverse order that you added them, because gribI doesn't let you add multiple LSPs with the same destination on top of each other. So that's our presentation.
To begin with, for the day 0, so what we did was we created the open config requests for the interfaces, configuring IPv6, IPv4, LLDP, loopback 0. And then we made modifications to the ZTP script so that it'll download all the XMLs. So it'll download the ZTP script from the ZTP server onto the router, and which will in turn download all these open config request files for configuring the LLDP interfaces and MPLS hostname and gRPC requests. And okay, so these are some of the screenshots. So this is to just clear the configurations initially. So we ran the retry manual ZTP sh, and which will clear all the configurations, and then that loggings show that the ZTP script has completed successfully. Okay, so after downloading all the XMLs that we have created to configure the respective configurations, so we can see that the device has been configured with the loopback, all the other interfaces, and LLDP, as well as gRPC and MPLS. So the loopback 0 was missing in the guide, but we figured it out and then we manually configured it. So that's about it for the day 0.
Thanks. Right. Good evening, everyone. My name is Anurag. I worked on the day 1 part. Just quick overview. We configured the IBGP sessions between R1 and R4. It's pretty much straightforward as per the documentation. We made use of netconf and SSH for the Ansible to speak to router and make changes. And we just spin up a couple of Docker images to make sure that we use OpenR and for the IGP, and tested the loopback reachability with the Ansible, set up the Docker image for collecting data, and combined all the playbooks into a single playbook. That's what single playbook is like. It's pretty much straightforward. Just importing all 4 playbooks. So the first one configuring the IBGP sessions, the second one bringing up the Docker for OpenR, the third one spinning up the telemetry, and the fourth one just checking the reachability. So in the end, we just see that everything is reachable. The telemetry one we wrote from scratch. So here we are making sure that Kafka Python is present. So we made use of pip module in the Ansible and installed that. We made sure that Docker is present, and eventually we just pulled the telemetry from this image and mounted the volume for the telemetry PY and just ran it on the Docker container as it came up. In the end, checking the reachability, when we after finishing all this, when we run the entire playbook, we just see that everything is reachable. The loopback reachability is fine, and it confirms things are working. We'll proceed with the day 2.
So day 2 was involved using a gribI as a interface connector to make changes to the RIB and the routing table on the routers. So there was one example that included path 3, which is the green one down here, and then the challenge was basically to figure out how to modify the next hop addresses and interfaces and MPLS labels to complete the other paths. It's all done over RPC calls. There was a particular bit of config on the routers that allowed this on port 5777. Here you can kind of see trace route from dev 2 to dev 1. The top instance is going from router 1 up to router 2, and then down to router 4, where you can see the extra hop in there, and then the lower one is a direct route between router 1 and router 4. Basically, depending on which script you pushed, you could modify the rib and also push and pop the MPLS labels. So in this case, this was the direct route between router 1 and router 4, or in this case, this was the route that went between router 1 up to router 2 and then over to router 4. And you can see here where router 2 basically like pushes the different labels onto the routes. The kind of stretch goal at the end was to turn this into like an automated controller, so you could use the telemetry data to basically notice like topology changes in the network, and then based on those topology changes, if an interface went down, you could then trigger one of these scripts to run that would change the path. So that was kind of the last bit of it. Yep, and I think that's it.
All right, so we did something a little different. Instead of the challenge that was presented, we did some Ansible with OpenBSD. So how many people have used OpenBSD before, out of curiosity? Okay, so people that have used it before, you probably know that they only release a CD with the current packages. Current packages are never updated, and also the system is never updated as far as the ISO goes. So you have to manually patch the system yourself or run syspatch, which for an automated deployment really is not that great. Ansible didn't have, or why OpenBSD? Because it's awesome and it has a great firewall. You can have end-device session sync and end-device IP failover and load balancing. As far as the problems, back to what I was saying. So there's no real good way to deploy OpenBSD in an automated manner. So what we set out is to fix at least some of these problems. So what we did today was we created 3 Ansible modules. The first one is OpenBSD syspatch, which takes the patches that are in current OpenBSD stable branch and applies them to a device. It can also revert them. That module is currently fully tested and everything works. We also made 2 other modules to kind of get toward a HA firewall deployment. The first one is OpenBSD CARP, which if you're familiar with VERP is a very similar protocol, but it's a little different. And then pfsync is the session state between multiple firewalls. So the code is currently available at GitHub. We plan on doing pull requests for them later, but have not done that yet. So for the first module, syspatch, all it does is take one variable state. You can either give it latest, revert will revert a single patch, and revert all will revert all of them. The CARP, you give it the variables you need to create a CARP interface, it does it. And then the same thing for pfsync, basically just a sync device, and that's about it. So we can try a live demo. All right, so. All right, so I don't know if anybody can see this, but we do have a current OpenBSD system here. If we do syspatch -L, we'll see there are currently 10 patches applied. And then if we do the same thing, we'll see that there are some available patches. We go over here and edit the payment file. this will rerun the playbook on the vagrant host. So right now, the first thing it's going to do is revert all the patches. We go over here, we can do such path -L, see that there are currently no patches applied. Next thing it'll do is apply all the latest patches, which probably wasn't the best order of things, because now this will take a second. But you can see as it is applying patches. There's no watch. So once it applies all the patches, it'll give us the output in a second. Gives you all the system, the standard error, standard out, return codes for every command run, along with like a summary of which patches were changed. And then we can edit this again. And set up a carp interface. Okay, so there's no carp interface right now. And now there is. So that's what we have. Future work would be setting up the firewall, more of the routing stack, non-base packages. But that's about it.
Number 9.
Hi, we are Fab4. Myself, Rishikesh, Shavi, Srini, and Alex. So we were working on the Cisco's project where we had to do a ZTP first, and then upon the automation of ZTP, where it automatically reloads the device to complete zero eyes, and then bring it back with the complete configuration where we would configure R2. We were also going to do R1 and R3, but there was another person also working on R3. We didn't want to disturb that. So that would be our future work. Now, after configuring using ZTP, the next thing was we did telemetry using Ansible. We didn't get to the part where telemetry was implemented, but we had the part where Ansible was used in order to configure BGP on the required routers. And then at the end of it, our future work was to implement telemetry so that day 2, we didn't do a lot of day 2. We did a day 2 where part we understood how the script would function to add a basic LSP that would be used to configure the path accordingly we require. But the achieved tasks today were day 0 and day 1. I'll let Srini continue with day 0 and come back.
Okay. Hey guys. So for day 0, pretty much the first step was like having the setup ready. So we made sure all the devices were up, like router 1, router 2, all the 4 devices, the ZTP. I mean, during this operation, router 1 was like down, which we were trying to troubleshoot, and which was not the use case, but eventually that came back up and we started with router 2. So the first step was we were kind of debating which XML templates to use, whether to use the open config interfaces, Yang model, or the Cisco ones, because online we were trying to find most of the Yang models that were used from the Cisco Yang model. So and then eventually we made the open config interfaces Yang model work. So we created those 2 templates, and then we started editing the ZTP client script. So in this, basically 2 steps. One is making sure you have the logic so that the XML, all the XML files that you have created, that is once the DHCP process starts, gets downloaded onto the device, and then it starts calling each of these config templates to configure the device. And then we did the testing of the ZTP process. The way we did it was, instead of using the refresh or like the repair that is provided via the console, what we did was like config replace, that basically replaces the entire device configs, erases it, and then it does the bootstrap, basically calls in DHCP and then calls in all these config files. We were able to achieve that. I have a couple of screenshots if you want to run through. Yeah.
Okay, so as Srini spoke about, these were the open config XMLs that we've created, one for LLDP and one for the interfaces. The interfaces were pretty difficult to find actually, but we were able to get it done. And then later on, the way we actually extracted the XMLs was, the ZTP script already had a get serial number method. So what we basically did was I created a serial number kind of variable in order to create an object of the class that they already gave us, and then extract the method using that. And then if you can see the host name, that's actually the router host name that I'm getting from the map, which is also present in the script that they provided us. So I basically did a for loop to go through all the contents of the map, and then if you see the XML underscore URL, that will generate a URL which will be used later on to do a dub. I actually use request in order to get all the XMLs present in that particular URL. So it'll return all the XMLs from that particular place, and then at the same time create a file and store it in the local in the directory where the code is running from. This basically extracts the different files, creates a new file with the same name of the XML. That's how we extracted the values. And then if you can see it here, so this is basically, and then the main thing was we used a manager, which was, two things were happening here. The script that they provided is already interacting with NCC client manager, the main one, and they also have another object. We basically imported their object so that it also imports the NCC client manager. And the NCC client manager has edit config, get config in order to either get the running config or edit into the running config, create a new config basically. So what we did was edit underscore config. And as I said earlier, we created a couple of files from the ZTP Linux server. Using those XMLs, we just read through them, and then as we read through them, we also configured them. One difficult thing we missed was we didn't actually commit it in the first, because of which the request was a success, but it was not actually committing the configuration. So it would have exit out and we would still not see the configuration. So the moment we did nc-manager.commit, the request completed, that actually committed the config, and we had a successful ZTP process. But as Srini said, the way we tested was completely different. We didn't do the regular repair mode in the Telesta console. I'll just go very fast. So what we basically did was we did commit replace, zeroize the box, and then run the ZTP, then just reloaded the box. It'll get a DHCP IP, boot up with the entire ZTP config and give us it. So it's basically hands-off process. You just have to reload and it'll do everything. So I'll give Alex a chance to actually go through the details.
Yeah. So day one, maybe. So day one was about setting up BGP with OpenConfig and telemetry. So we didn't do telemetry, but I will talk about BGP and what we did. So we create a new Ansible with the basic config, management IP, and all the neighbors we needed. So the thing is, we want to have an inventory was the source of the backbone. So if I remove a neighbor, I will remove to all my peers, and that's it. So I create a Python file based on what we had, and the thing is, we can change from Cisco to Juniper with this Python with only OpenConfig if Juniper and Cisco use the same attributes, because under this basic it's simple, but if you want to use some policies, it can be tricky. So after that, we just did some playbook and have two tasks. So the task was to configure BGP, and the second was to ping loopbacks. As we didn't put the IGP, it wasn't working as a ping loopbacks. That's it. So do you want? Oh, I think we don't have any time.
Yeah, if you can wrap it up in 10 seconds.
Yeah.
So to tell the truth, the day two, we just started understanding the situation. So future work would be use the telemetry data from day one. And we were pretty much on a basic approach. We were thinking of using ping in order to ping between the different devices. And if ping fails for one, it automatically creates a request for the next LSVP. But we weren't able to do that. Other than that, we've learned a lot through this exercise for day 0 and day 1. Thank you so much. Thanks.
All right, I was on the team that was heading up the day 0. We started where everybody else did, was trying to update the ZTP NCC. Pretend there's a screenshot here. Starting. We tried to follow the instructions as best we could. We started with the interfaces and the LDP. We ran into the same issue where we couldn't get the OpenConfig model to work properly with the box. We were striving to keep the rules, use the OpenConfig, but we never ended up getting it to work properly. Yay. So we updated for those two, the interfaces OC, because we couldn't get those to work properly, but we did get the other three to work. We updated the ZTP functions to include the opening of the files and then loading them directly into the config. What was really, and I'll get into, what was really good is we actually committed on every single snippet, which helped us troubleshoot later on. This is us later on in the actual script. We get the serial number, and then we go through. We're actually just using the raw shell command to wget off the server the snippets of config, and then we were calling that function again every time. So what worked? The OpenConfig example that were provided loaded properly, so that was great. Our team was nice, even when we couldn't get the interfaces to work. They didn't get really mad at us, so that was good. And actually committing after each stanza was really helpful during troubleshooting because we could verify that the host name was being configured, that the gRPC was being configured, everything was being set, and we didn't have just one blob of XML that we had to parse through, so that was good. What didn't work was we had a tough time understanding the correlation between the OpenConfig model and what the Cisco device actually needed. So when it got to configuring the interfaces, we were kind of stumped. Troubleshooting the ZTP was a little bit tough because we couldn't understand over console all of the messages, reading properly. If you guys have been on console before, you know that sometimes you can't scroll back on the messages. So we could have done a better job, and I'll get into what we're going to do next time. And then there were some errors. We realized the same thing, that the loopback interface wasn't being configured, so every time we commit it, it would cut off the NC client, which was an issue. And then resetting and restarting the entire thing through the UI was pretty rough. We're also getting a lot of default messages of hackers trying to log in using random names, which is difficult, sent red herrings for us. So for next time, we're going to read up on on actual how ZTP works on the iOS XR so that we understand better where we can fit in the stuff that we needed to do to get it configured. Study a little bit better on the OpenConfig model and how it relates to the iOS XR. Setting up that syslog server at the very first probably would have been pretty helpful. And then do better logging within the script itself so we could understand the outputs that were coming out.
So for day one, we were able to configure the BGP sessions through OpenConfig. Rami actually did all this part, and at the end everything was working. We also had a little off script. So we actually noticed that the Ansible repo was using a lot of script and was not using the native module. So we actually redesigned the whole Ansible project to use all the native Ansible module for Docker and all of that. We were using, for example, instead of having one file for every router, we were using templates. And so we were able to deploy OpenR using all the native modules and without having any Python script running directly. That was pretty nice. We also wrote a Python script that was listening on the Kafka bus and that sent the information to a time series database. And so later on in the demo, we'll show you how that works. And so for the day two, and I think it's the most interesting part, we actually managed to have a full day two working. So the team set up a controller that kept track of all the paths and interfaces and was able to listen to the bus. And just as a last part, we want to show you a little demo where it will actually shut off in one interface, and we should be able to show you the traffic getting. So right now you can see the traffic is actually going on this interface, and it will shut down this interface, and the traffic will automatically basculate on this one. So it's going like through the whole loops, and we have all the data going through Kafka. The controller is listening to Kafka for the states. It will propagate that. And then I think we have a latency of 30 seconds to a minute, but you should see the traffic moving on the other direction. That was the test we did before. You can see how that was. Sorry? Here it is. Thanks for your time.
Sorry for the technical difficulties. So we are Team Buffs. We are 4 students from University of Colorado Boulder, and we were joined by another student from Ball University, Casey Jones. And we were given 3 objectives to solve, and we had a tremendous experience solving them, and we mostly implemented all the objectives. So this was a topology given to us, and the day 0 part was implemented by me. In the sense, we were given a server where we had to provision a router based on zero-touch provisioning. And this was the XML coding that was done. In the sense, we had to configure interfaces, we had to configure the loopbacks, and we also had to configure all the GMPC's ports. So in the sense, we had difficulties in getting the XML code ready, as well as bringing up the interfaces. So thanks to the Cisco team for helping me with the deletion part of the shutdown interface, so that the interfaces were coming up. And this was a code snippet that we followed, where we kind of created a dictionary, and then we appended the server's URL in order to form a path to the XML file. And after that, the XML files were read, and a commit was made at the last. So the testing was done in 2 phases. In the sense, we did the on-box testing, as well as we did the repair testing as well. So during the on-box testing, when we run the script, these were the log messages that were displayed. And when we were going for the repair testing, we pointed the file to the Python script that was made in the DHCP server configuration. And finally, when we repaired it, when we made a repair, it took around 10 to 12 minutes for the ZTP to make the device come up. And the device was, these are the log messages that were seen during the ZTP messages. So the initially, like ZTP will be applying the configuration, and after that, you'll be seeing a reply message of what XML transactions has been made. And finally, when all the configurations has been applied, you'll be seeing a ZTP completed message. So moving on to day 1, my friends will be continuing.
Hi, about day 1, we took up the fun method using the YDK file, and using the parameters that were already defined in the Ansible host file and extracted in the YML file that were passed on to the code that we wrote and extracted. This was run using Ansible, and we could configure BGP on all of the 3 routers. Sorry, on R1 and R4. And this was verified by installing OpenR on the individual routers and checking the application routes being populated on each of them. And moving further, we also got the telemetry part, where we ran the Docker file on dev 1, and on dev 2 we ensured that we were able to see the telemetry data, and we were in the process of parsing it. Moving further to day 2, I'll hand over.
For the day 2, we have seen that we have 5 paths which we had to handle, and path 3 was given as an example. So we could understand the basic mechanics of how each JSON file was created and how they are mapped internally. And based on that, we could write the JSON files and the required Python script duplication for all the different paths. And we could achieve all the paths successfully. And this is just an example of how we have done that, and how this is like the next hop, the IP address, and the particular MPLS label we have applied to. And that is the script output of how it's being applied sequentially. And once you see the message it's being true, you can actually go into the device and check the actual configuration with the tag, the interface, and the next hop IP. And once we could do that, we could verify the ping across. And this has been done for all the paths which were given. We had few troubles with R2, which so for the router 2, because that was also being parallelly used for the ZTP, we had little trouble with the initialization of the OpenR on that router. So we had to troubleshoot a lot for that, but it was good experience because we could actually map everything we had learned in the JSON format, and we were very clear about what was happening. And thanks to the organizers, they actually helped us understand that OpenR was the issue in that case. And after that, we could implement it fine. And for the telemetry part, we could get the telemetry data on the dev2 device received and processed. And for the parsing part, we could write a script to parse the data, but we didn't implement the change of LSP stack mapping to that specific event. That was sort of because of the time delay, but we had a script which we were processing the logs on the go. To summarize, these were all the learnings. So I would be talking in for the whole team, I guess, because all these tools were, few of them we just heard, few of them we have implemented in a basic scale, but using them at this scale and in few places totally different way rather than how we have done. It was definitely very exciting, and we definitely are planning to look back onto all these tools and see how we can implement in different use cases. And we are happy, we are definitely, all of us being students, so I think we have done a good job in implementing all the required implementation, and mostly we have covered everything, so that was good experience. So we are Team Boss. Thank you very much.
Hi everybody, we are the Ethical Networkers. My name is Lauren. We have David, Victor, Eric, and then Dan is not with us. So Eric and I were working on day 0, where the basic objective was to start up the equipment and ensure basic connectivity to the network. Eric and I are newbies, so we had a lot to learn. And Eric is going to actually explain what the screenshot is.
So just like everybody else, we had to go through and configure the ZTP script. So we went through, did the LLDP and the interface. Here we had the gRPC and went through, created these into the XML files using the OpenConfig. Just like the other groups, we had some issues with the Yang model and also ran into some error messages from the ZTP. Like Lauren said, we were both pretty new to this, so we learned a lot today. How to configure a router from a blank slate, the whole concept of ZTP, along with the Yang and the data modeling frameworks. So then we're gonna hand it off for day 1.
Yep, so I was working on day 1 for the guys. So one of the things I think nobody noticed, that red line there on the screen, don't ever do that in Python. That's a mutable default variable. It will bite you. Not in Ansible case, because it will be instantiated once, but yeah, this part, always do that. Never do that, always do that. Just free advice. Yeah, but on the day 1, on the main stuff, yeah, as some of the other teams, it was for me first time to work with the YDK. Spend a lot of time trying to narrow down the exact, Python tree of objects to the XML tree. And as you can see on the diff, got everything covered, and that was pretty much the main part of day 1. So once that got this working, all the rest of the items was, fairly easy to do, like, rearrange the playbooks and run telemetry, which is already done for us. So that's me. Exploring XML, OpenConfig XML, and again, trying to narrow it down to the YDK was kind of fun part and new for me. I figured it out. Happy it works. Thanks.
Hi, I'm David. I was working on the day 2 stuff. So I haven't worked with gRibby before, so I wanted to get an idea of the structure of the JSON, make sure I understood what it was before I started to expand to that larger label mess. I wanted to streamline it down to just one simple connectivity, which was from router 1 to router 4 across that direct link. So I built the configs for that. I got the labels applied, but unfortunately it didn't work for me. So spent a lot of time to get to that point, and also tried to do some debugging, but wasn't able to get past it. But that's it.
All right, voting's open. The link's posted on the Slack channel. I'll also put it up on the board. Okay, we're going to call it at this point. So with 39% of the vote overall, pod 10. Congratulations. Followed by Team Buffs and Neural Clack. So thank you, everybody. Great work, everybody. I want to thank our sponsor, Cisco, who provided all this great merchandise that we're going to raffle off right now, as well as tons of resources in making this hack day possible, this hackathon possible, and to Sudo as well for providing all the infrastructure, all the cloud infrastructure that you use today. So please, let's give them a hand as well. And as soon as we finish up with the raffle, there's going to be a reception out in the atrium with snacks and drinks.
Sounds good. So let's start with small Anker power charger.
Oh, I get to choose?
Yes. Okay, Kyle Birkland. Yeah, come here. Thank you. Echo Dot.
David Rogers.
Oh, you are lucky. Thanks. Okay, some Garmin Smart Tracker.
Okay, Chrissy Sutton.
Yep.
Oh, thank you so much.
Thank you.
I needed one.
Even more data now. Okay, bigger anchor to stay online more.
Apruva Shastri.
Yay! Congrats. Okay, we are getting serious. Jabra Elite Sport earbuds.
Okay, Curtis Schlongala.
Thank you. Okay. So this is tough one. Be ready to carry it home. Eka Show.
All right. Jeff Bantig.
Yeah.
Sorry, can you tell if it's an A or a U?
Yeah.
Jeff Bartik?
Yeah, it's you.
Yes, that's me.
Oh, sorry.
Okay. Baze Sound Sports Free.
Chris Eisner.
It's orange. Will fit your sneakers.
Hey, we're right. Thank you.
Thank you.
Oh, now it's the big stuff.
Yeah. Let's go for Apple Watch Nike series.
Ed Paxtow.
Thank you. GoPro 6. Any bloggers here?
All right, Dan Norton.
Whoa. Well, do you want to try one more?
Okay.
Yeah. Oh, we do not have his number, sorry.
All right, try number 2. Jamie Botella.
Yay! Thank you. So let's shuffle it better for last one. iPad.
All right, Andrew Damp.
Yay! Thank you. Well, thanks all for your participation today. I hope it was a great hack and we learned a lot from both sides. And thanks to Suta for reliable infrastructure. And we all glad to see your faces and your skills over here today. Thank you.